Graphing in vertex form. In this video, you'll learn how to graph a quadratic function given in vertex form, showing a max or min in the y-intercept. You'll also learn how to find a maximum or minimum of a quadratic function given in vertex form without first graphing it. So the vertex form of a quadratic is f of x equals a times x minus h squared plus k, where a tells us the direction and the width of the parabola. If a is greater than 0, then the parabola will open upward. And if a is less than 0, then the parabola will open downward. And the coordinates of hk will tell us the vertex. The line x equals h creates a line of symmetry splitting the parabola in two. So we'll keep this in mind as we look at some examples. Let's graph the equation f of x is equal to negative 2 times x minus 3 squared plus 4. Our first step is to identify the vertex. We can see that h would be 3 and k would be 4. So our vertex will happen at 3, 4. So we'll plot this point on our graph. Now let's decide the direction of the opening. Our a value is negative 2, so since it's negative, we know that our direction of the opening will face downward. Now we're going to find two additional points so we can see the shape of this parabola. So we'll take the equation they gave us and we'll replace x with one x value before the vertex and one right after the vertex. So we'll start with when x is 2. 2 minus 3 will give us negative 1, and negative 1 squared will give us positive 1. Multiplying negative 2 times 1 gives us negative 2, and adding that to 4 gives us a final answer of 2. So we'll plot the point 2, 2 on our graph. Now we'll replace x with 4 since that's one number after the vertex. 4 minus 3 gives us 1, and 1 squared is still just 1. So multiplying that by negative 2 gives us negative 2, and then we'll add the 4, which gives us a value of 2 again. So we'll plot the point 4, 2 on our graph. And this makes sense because the line of symmetry happens where x is equal to h, or the x-coordinate of our vertex. So both sides of that line will be the same. Now we can just connect the dots to form the graph of this line. In this example, we want to know which of the following equations has a vertex at 1, 3. If we look at our first example, we can see that h is 1 and k is 3. So our vertex happens at 1, 3. So this is the answer we were looking for, so we don't have to do the rest. In this example, we're going to use the equation y equals x minus 2 squared minus 8 for the following questions. First, we want to know where is the vertex. So we can see that h is 2, and k is going to be negative 8. Since we're used to adding k, and this time we're subtracting, k would be the negative 8. So our vertex happens at 2, negative 8. Now we want to know where is the y-intercept. So we'll take the equation they gave us, and we'll replace x with 0. And now we'll just simplify. 0 minus 2 will give us negative 2, and negative 2 squared gives us positive 4. 4 minus 8 will give us a final y-intercept at negative 4. Now let's graph this equation since we know the vertex and the y-intercept. We'll start by plotting the vertex. So we'll put this at 2, negative 8. And then we know our y-intercept is negative 4. So we'll put this on the y-axis at negative 4. Since we know that the line of symmetry happens at the vertex, we can put another point directly across from it to show that mirror that the line of symmetry would have. Now we'll just connect the dots. In our last example, we're going to match each graph to the equation that represents it. We can see that two of our parabolas open upward and two of our parabolas open downward. They all have the same vertex though, so we'll have to look at the openings to decide which one is which. Let's look at the ones that have a downward opening first, so their a value will be negative. So our first equation has an a value of negative 2, and our last equation has an a value of negative 1/3. Since negative 2 will have a smaller or skinnier parabola, we can see that our first equation would be that blue line or the B graph on our example. And our last equation would be the red line or D, since the a value of negative 1/3 says the parabola will open up a little wider. Now let's look at our two remaining graphs that open upward. We can see that our second equation has an a value of 1, and our third equation has an a value of 6. The a value of 6 tells us that it would be a really skinny parabola. So we can say that this equation would be C, or the green line. And then our last equation, the second one we have, is going to stay that black line of a, since it just has the a value of 1. Now let's summarize what we've learned. The vertex form of a quadratic makes it easy to identify the vertex and whether it's a maximum or minimum. The value of a tells us the direction and the steepness of the parabola. And the line x equals h creates a line of symmetry that can help us identify more points on the graph.